Okay, so now we're going to do a bit of revision of cross-validation and see whether it can be applied to variable selection. So here is the idea. We are going to do it on this diabetes data set that you can also download if you want. In this data set, the response variable, I just renamed it to Y, but basically it tells us whether a person has diabetes or not, right? And we have a number of predictors, 16 predictors, as far as I remember. One of them, H, is numerical. The rest are binary categorical, yes or no. So this is the list of all variables that we have here. There are 17 of them, and so 16 predictors and one response variable. So now what we could do, we could sort those variables according to correlation with the response variable, right? So for each of these variables, we just compute the correlation with our response, with our Y. Well, and we could just pick some like those that have the highest correlation with the response. So we need to decide about the number of those that we want to include into the final model. And let's say if we want to pick the 4 variables with the highest correlation with the response and construct a logistic regression, we can do it. So the 4 variables with the highest correlation with the response are these 4, right? So polyuria, polydipsia, gender, and sudden weight loss. So then we can construct a logistic regression, and then we can estimate its accuracy via cross-validation. So in this case, it is a 5-fold cross-validation. So is the correct procedure? No, this is a wrong procedure. So this is a wrong procedure because basically variable selection is a part of training, and when we computed the correlation coefficients, we did it on the entire data. So that includes test and training data together, right? So we shouldn't do it, right? So if we want to, and if we do not have enough data, and if we want to somehow use cross-validation to do variable selection, then the correct way is to do these 5 cross-validation loops. Recall that in 5-fold cross-validation, we split our data into 5 so-called folds, and then we loop it 5 times, and every time we select all the folds except for one. Like in on the second iteration, we select folds 1, 3, 4, and 5, train our model on these observations, and then we validate our model on fold 2. So we find the cross-validation error on fold 2, and then we take the average of these cross-validation errors. So we could apply a similar procedure for variable selection, so which means that we could do it 5 times. So every time we remove one chunk of our data, find correlation coefficients, and here we report the 4 most highly correlated variables with the outcome. So note that this polyuria always appears first, so we can probably believe that it is legit. It is indeed the highly correlated with the outcome. So polydipsia always appears second, so it is legit, right? But out of the 3 other variables, so gender appears 1, 2, 3, 4 times. Sudden weight loss 1, 2 times, and partial paresis 1, or gender appears 5 times, right? So even better. So it is probably legit. But sudden weight loss appears 2 times, and this partial paresis appears 3 times. So it kind of wins, but we do not have a very strong evidence that partial paresis is better than the sudden weight loss to be included into the model. So if we really want a model with 4 predictors, right? So, but this is somehow how we should do cross-validation for variable selection. So we should run our loops, and every time we report variables that are most highly correlated with the outcome on just some part of the data. All right, so here is the first quiz for you.